Welcome everyone. The question that is shown on the screen, it is from the CBSE 2026 physics question paper. In the given figure, a steady current I flows through the circuit. When the points A and C are connected by a wire of negligible resistance, find the potential difference between the point B and C. Okay, so here E1 cell is there and 6 volt is the EMF value of this first cell, which is connected between A and B, and 1 ohm is the internal resistance. 4 volt is the voltage of the EMF cell and 3 ohm is the internal resistance. So I can redraw this, that is, if I say this is the 6 volt and internal resistance 1 ohm is in series with that. That is basically represents the electric cell between the point A and B. Now here it is A, this point is B, okay, and this 4 volt and 3 ohm I am just writing down, this is in series and this is in 4 volt, okay. So this is the equivalent of this circuit, but one thing is written there, one thing is drawn there, that is a current I is flowing in that direction. And if in the question it is instructed that if it is connected by a negligible resistance wire, that is no resistance is connected between A and C, what is the potential at the point A? The same potential would be at the point C. We can say V and Vc are equal, okay. So this current I which is flows through here, the same current flows through like this way and hence complete the circuit, okay. Now if I use this KVL or Kirchhoff's voltage law, then I can write it down, that is starting from point A, okay, from point A it is moving like this way Vc. So through 3 ohm, okay, through 3 ohm I current is flowing, so 3I. It just strikes the negative terminal of the 4 volt battery first, so -4. After that it is flowing through the 1 ohm, so +1 multiplied by I, okay. Then it strikes the one thing I have done a mistake there, here 4 volt in case of the positive plate is this side, so I have to say this is 4, okay. So it hits the positive plates first, so 3I plus 4, clear. After that 1 into I, and after that -6 equal to 0. So that is the KVL says. I repeat again, through the 3 ohm I current flows, so 3I. It after that the positive potential of the 4 volt, so +4. After that 1 multiplied by I, okay. After that -6 equal to 0, okay. So 3I plus I equal to 4I. -6, if it goes on this side it becomes +6, 4, so 6 minus 4, so 4I equal to 2, 6 minus 4 is 2, so I equal to 2 divided by 4 equal to 1 by 2 ampere, we can say. That I current is flows through this like this way. Now what is the potential difference between the point B and point C? Okay, so I am redrawing this, what is in between the point B and point C, I am just redrawing this like this way. So this is my 4 volt supply and internal resistance of the supply, that is the 3 ohm I have drawn here, and through this 3 ohm the current is flowing from C to B and the current is 1 by 2 ampere or 0.5 ampere, okay. So obviously across the 3 ohm, obviously this side is positive and this side is negative because current is flowing from C to B, okay. Now if I think that is the 4 volt here, now this is the positive and this is the negative, okay. So the current when it is coming out from it, okay, when if I allow this 4 volt to flow the current from B to C, that is in the opposite direction, but actually the current when it is placed in the circuit, the main current is flowing from C to B. So if I say what is the potential difference between the point B and C, so that is VBC, 4 volt and 1 by 2 ampere multiplied by 3 ohm, this potential drop or the potential drop across the 3 ohm is opposite to each other. Okay, because through the 3 ohm 1 by 2 ampere or 0.5 ampere which is flowing from C to B, but if I allow the 4 volt to flow, that is from B to C, so direction is opposite to each other. So that's why if I say 4 volt is positive, then 1 by 2 ampere multiplied by 3 ohm is negative. So it is 4 volt. Ampere into ohm is also volt. 3 by 2 is 1.5. So 4 minus 1.5 is 2.5. So 2.5 is the voltage between the point B and C in this circuit. 2.5 volt is the answer. Thank you all of you.